Yeah, kind of like an unfolded pyramid. Okay, here are the answers to the triangle inequalities worksheet. This was a very good homework. It covered everything that would need to be covered as far as triangle inequalities. Did y'all like this stuff? I think it's kind of fun, isn't it? It's so different from what we've been doing. It's kind of like a puzzle to find out what goes where and what order they go in. So which ones would you like me to work from this? I'm so glad it makes you think. You need help with 20, okay? When it says, what are the possible lengths of the third side? What you do is you take the two sides that you know and you add them together, and that's your max. Then you take the two sides that you know and you subtract them, and that's your min. So like number 7, the sides were 3 and 4. What are the possible lengths for the third side? So for the third side, the very largest the third side could be is 7. And the very smallest the third side could be is 1. So x, the third side, is smaller than 7 and greater than 1. That's why the answers are written as inequalities. It's a range of values. The third side could be between 1 and 7, non-inclusive. Starting with number 17. There we go. Okay, order the sides from least to greatest. Was that the directions? I believe so. We would want to find all of our missing angles first. So we would do 180 minus 30 divided by 2. And we would get that this is 75, 75. Then we would do 180 minus 72 divided by 2. And we would get 54, 54. Now I would work with, let's see, this is B and it has a tick mark, so this is also B, right? And that's A and it has a tick mark, so this one's also A, so we just need to keep that in mind. Let's work with this triangle first. Let's list the sides from least to greatest. So the least one in this triangle would be C. Wait, oh. Okay, number 17, here we go. So you would start by finding the base angles of that first triangle, 180 minus 30 divided by 2. So that one was good, 75, 75. Then you would look at this next triangle. Now, we haven't officially had this lesson yet, but when you have an isosceles triangle, the angles across from the tick marks are congruent. So if that angle is 72, then the other angle across from the tick mark is 72. And so the missing angle would be you add up 72 plus 72 and subtract from 180. And so that makes this angle 36. Okay, there we go. That's much better. So now let's look at that triangle and let's order the sides from least to greatest. C would be the least because it's across from 36. B would come next. B also goes there because we have our tick marks. In the next triangle, B would be the smallest, and then A would be the largest, because A is across from 75. So just remember, like I was saying yesterday, you do have to do one triangle at a time. You can't compare, oh, C is across from 36, and B is across from 30. You can't compare an angle from one triangle to an angle from another triangle. Number 20, you would start with this 22 right down here. And you would use the 90 degrees, and you would look at this triangle right here. In this unit, you have to be able to see things. These triangles need to be able to pop out at you because the diagrams normally have a lot going on, and you need to find what's important. In that triangle, if I subtract those two angles from 180, I would get that this angle is 68. That's going to create a domino effect. 68, 68. Then we can do linear pair. 112. Then right here, we can do 180 minus 68 and divide it by 2. 56, 56. Then we can do linear pair. 180 minus 56, 124. Then we can do alternate interior angles, 124, 124. Over here we can do alternate interior, 112, 112. Then we can do a linear pair again, 68, and then we can add those up and it happens, corresponding angles, 90 and 90. So we're really just using our knowledge of parallel lines on that one. All right, on 23 we have all the angles. That's wonderful. We have all the angles. This got cut off. This is an N. So we're going to list the sides from shortest to longest. Remember, you have to work one triangle at a time. I'm going to pick the one that looks shorter, that looks smaller, right? So the shortest side would be across from 50, MQ. That would be the shortest side. The next side would be across from 60. That would be our medium side, QP. Remember, the order doesn't matter. And the largest side would be across from 70, MP. Now what we want to happen is we want the largest side of one triangle to be the smallest side of the other, or else we're in trouble. And I think that that's what happens, is because this is the longest side of the purple one, but look, it's the shortest side of the next one. So we leave off here and we start here, and that's perfect. So the next largest one would be NP, and then the very largest side of this whole figure would be MN. 29, which numbers could represent the lengths of a triangle? Remember how to do this? You take the two smallest. If the sum is greater than the third side, it makes a triangle. If it's not, then it doesn't. If the sum is greater than the third side, it makes a triangle. So I always circle the largest one, circle the largest one, circle the largest one. You add up the two remaining. 30 is not greater than 30, so no. On this one, 6 plus 8, 14 is greater than 10, so yes. 7 plus 8, 12. 12 is not greater, so no. If the sum is greater, you put yes, and if the sum is not greater, you put no. And that's how you do that one. Polygons. The word polygon comes from Greek roots. Poly means many, so more than two. Bi is two, and then poly is many. And then gon means angle. So a polygon has many angles. Here are some polygons in the real world. We've got our soccer ball made up of hexagons and pentagons. We've got road signs. Almost all road signs are polygons of some sort. We've got, not the gazebo itself, but if you did the bird's eye view, I was trying to find an example of an octagon or a decagon. The bird's eye view of the top of that gazebo would be an octagon or a decagon, depending on the gazebo. Stained glass is usually made up of polygons. There aren't a lot of curves in stained glass, so a lot of times it's made up of polygons, and a lot of times quilts are made up of polygons as well. There are all different polygons out there. To be a polygon, you have to be a closed, plane figure with at least 3 sides that are segments. That is a loaded definition. It has to be closed. There are no openings in your polygon. That's why that is not a polygon. It's not closed. It has to be a plane figure. That means it's 2D. You can fit it on a plane. So a 3D figure can't be a polygon. It'd be a polyhedron, but not a polygon. It has to have at least 3 sides, and the sides have to be segments, no curves. Okay, so those are the qualifications to be a polygon. Your sides are not allowed to intersect. Your sides are not allowed to intersect. This is not one polygon. This is actually 2 separate polygons. The figure itself is not a polygon. Good. You said that before I said it. Good job. There are 2 categories of polygons. There's convex and there's concave. You might have heard this in science. Convex and then concave. I always think of my contacts when I think of convex and concave. When you put them on your eye, they're convex, but sometimes they flip and become concave. Anyways, convex means it's pretty much every polygon that you picture is usually convex. Concave would mean one of the sides caved in. It's like someone took one of the sides and punched it in. So concave means one of the sides caved in. I want to go back to this slide real quick. In this quilt, this is a concave polygon. You see that? That is an example of a concave polygon. Look, the side kind of like caved in right there. Okay. How do you test if it's concave or convex? If you draw all the diagonals and they all lie inside, then it's convex. If your diagonals of even one of the sides lie outside, then it's concave. So see how M to W, that dotted line, lies outside the polygon? That's what makes it concave. The sides caved in. Why was the sphere a polygon? Rishi, the sphere was not a polygon. I was just showing that a soccer ball is made up of hexagons and pentagons. It's not a polygon itself, but it's stitched together. It's polygons stitched together. So let's try out our newly found knowledge. Is it a polygon? If it is it concave or convex? Number 1, believe it or not, that is a polygon, but it's concave because look, one of the sides caved in right here. I can draw the diagonal and it lies outside, so that's a concave polygon. Next one, is that a polygon? No, because the sides aren't allowed to cross each other. So that would not be a polygon, and we can't say if it's concave or convex because it's not a polygon. Next one, is it a polygon? Yes, and it is convex. None of the sides caved in. This one always makes me think of like a huge diamond ring. Like I just see it like a sideways diamond. Yeah. Anyways, okay. All right, more stuff. We're going to keep going. An equilateral polygon, what do you think? It's kind of obvious. Equilateral, equa means equal, and lateral means of a side. So an equilateral polygon is going to be a polygon. But does it not disappear? Come on. Whoosh. There we go. A polygon with all sides congruent. Conversely, an equiangular polygon is going to have all, oh, it's got sound effects, all angles congruent, just like it sounds. So then a regular polygon, which is the word we were working up towards, a regular polygon is going to be both equilateral and equiangular. We're going to use that word a lot, regular polygon, and I'm going to expect that you know what I mean. A regular polygon has all angles congruent and all sides congruent. A lot of the polygons we're going to work with are going to be regular polygons. Don't say that. Oh gosh. Okay. All right, to get this out, it was one of the things attached to the calendar. It's called Polygon Angle Sum Discovery. We're going to work through it together because of a time constraint. I was going to have you discover all these things about a polygon, but instead we're going to discover it together instead of it being an individual thing. So, how you can find out how many degrees are in a polygon is going to be just like the warm-up. You're going to divide it into triangles. Now, the first one doesn't really make sense. A triangle has 3 sides, so therefore there's one triangle. Every triangle has 180 degrees, so 1 times 180 means it has 180 degrees inside the triangle. If it was regular, this is my regular column, if it was regular, how many degrees would each angle be? Thank you. 60 degrees. 180 divided by 3. So if it's regular, if it's an equilateral triangle, each angle would be 60 degrees. Okay. So the next one on your list, so we already did that. The next one's a quadrilateral. So how you would go about this is you would say, I can divide a quadrilateral into 2 triangles, right? So it's got 4 sides and it has 2 triangles. So how many degrees would be inside a quadrilateral? Well, 2 times 180. So a quadrilateral would have 360 degrees. And then to find one interior angle, remember this is only if it's regular. To find one interior angle, you would take the sum and divide it by 4. 360 divided by 4. So if it's a regular quadrilateral, it's a square. If it's a square, all the angles are 90. Next one. Pentagon. It has 5 sides. I could divide a pentagon into 1, 2, 3 triangles. 3 times 180 is, very good, 540. And then you take the 540 and you divide it by 5 because there's 5 angles and you want to spread those degrees out evenly. Yes, Ganesh, we're filling out that table one by one by one. 108, very good. Do you notice a pattern between this number and this number every time? 5 to 3, 4 to 2. What do you notice? 6 to 4. Oh, V knows. Every time you take the number of sides and you subtract 2 to get the number of triangles. Look, 6 minus 2 is 4. 5 minus 2 is 3. 4 minus 2 is 2. So the number of triangles you can draw is 2 less than the number of sides. It's always 2 less. Sum of the interior angles is 720, and one angle would be 120. I'm going to keep going. So you're always taking this number right here, and you're multiplying it times 180 to find out how many degrees are in the polygon. Heptagon. Did y'all know that a 7-sided figure is called a heptagon? It actually has 2 widely accepted names. Do you know what it's also called? A septagon is the other accepted name. Hepta or septa. So you do need to know both of those. For the quiz on Monday, you need to know this vocab. So you have a little bit of work to do over the weekend, okay? 7 minus 2, it's going to have 5 triangles. The sum of the interior angles is going to be 900 degrees. And then one interior angle, we don't write decimals, we write fractions. One interior angle would be 900 degrees. I know it's weird. 900 We don't write decimals because they're inaccurate. 900 divided by 7, it doesn't truncate. Like, it goes on forever and ever. So when a decimal goes on forever and ever, you can't just round because you're not exact anymore. When you round, you go from perfectly exact to approximate. We like to be perfect, not approximate. So only reduce it if it's a whole number, or if it's like 70.5 and there's nothing comes after it, then that's fine. But if it goes on forever, then you need to write it as a fraction. Math, enter, enter. We are not going to approximate it, Lars, unless the directions tell you to. Octagon. Octa means 8. An octagon has 8 sides. You can divide it into 6 triangles. 6 times 180 is 1080. And one interior angle would be 135 degrees. As our shapes add more sides, what's happening to each interior angle as we get more sides? It's growing. So our angles are getting more and more obtuse, right? The larger the number of sides, the more obtuse our angles are. Nonagon. Practice saying it. Nonagon. Nonagon has 9 sides. That would mean you can divide it into 7 triangles. 7 times 180 is 1,260. And so one interior angle would be 140 degrees. 1,260 divided by 9. Polly is still gone. Okay. Decagon. 10 sides is a decagon. You could divide it into 8 triangles. Sum of the interior angles would be 1,440. And one interior angle divided by 10 would be 144 degrees. The last one we did skip 11. I actually don't know what an 11-sided polygon is called. You can Google it. The next one we went all the way to 12. It's called a dodecagon. You need to know this word as well. If I ask you what a dodecagon is on Monday, you need to know. And so a dodecagon has 12 sides, 10 triangles, 1,800 degrees and 150 degrees for each interior angle if it's regular. I'm making you write really quickly, aren't I? Okay. Moving on. So, we do not want to have to memorize this table. Who wants to memorize this table? No, sirree, Bob, we do not. Well, if you want to, then that can be your homework over the weekend. For those of us who don't want to memorize a table, we want a formula that we can use no matter how many sides I give you. If I say it's a 27 gon, if I say it's a 50 gon, I want you to be able to tell me how many degrees are inside. So we need a formula that would represent the sum of the interior angles. That's what we're doing right now, Rishi. We're doing the n gon right now. So if a polygon has n sides, what did we agree? We took the number of sides and we subtracted 2. And that was the number of triangles. And then what did we do with the number of triangles? Multiplied it by 180. Very good. So the sum of the interior angles, the formula, write it down, n minus 2 times 180. The number of sides minus 2 times 180. N minus 2 times 180. You're going to get very familiar with this formula. How would we find one interior angle if it's regular? How would we find one interior angle? Good, Rishi. Divided by n. N minus 2 times 180, and then divide it by the number of sides. Write this down. This is an important formula. Good. What if it isn't regular? Then every angle is going to be different, and you'll have to solve it differently. No, you're not going to memorize the table. Okay, now we're going to move on. That was interior. Interior, check. We're done with that. Now we need to go over the exterior angles of a polygon. So we now know how to find the interior. Exterior angles occur when you take a side and you extend it. When you extend the side, you get an exterior angle. If a polygon has 5 sides, it's going to have 5 exterior angles. Okay, it's going to have the same number. So, to be able to tell you how many degrees are in the exterior of a polygon, first you need to tell me how many degrees are in a circle. How many degrees are in a circle? Have you learned that? 360. Good. All circles have 360 degrees. You're giving it away, guys. All right, so I have a little demonstration real quick. The red, the green, and the yellow represent the exterior angles of the triangle. Now, I can do whatever I want to this triangle. I can make it look however I want. I can make one angle really small and one angle really large. But when I shrink my triangle, whoa, now it didn't shrink all the way. But what do you see? Do you see how those angles formed a circle? A circle has 360 degrees, right? Okay, let's reset it. Even if I make it look crazy, like, okay, maybe it won't work for that one because that triangle is like crazy. But if I make it smaller, even though the angles are all different measures, they're going to come together and they're going to form a circle, 360 degrees. Now that doesn't just work for triangles. Let's try a quadrilateral. Let's make sure it doesn't look like a square. I don't want it to be perfect. I want this to work for any polygon, well, any convex polygon that I want. Okay, so let's make it smaller. We're going to shrink it, and we're going to realize that those 4 angles come together to fit like puzzle, and whoa, form a circle, 360 degrees, just like the triangle. Let's try this one. What is that? A pentagon. It's not a fake circle. If I shrink it, whoa, it becomes a circle too. Now, let's see, can we add more sides? I don't think we can add more sides. I think that this is the largest that it gets. One less side. Oh, now it's a quadrilateral. And we can shrink it. Yep. Okay, so anyways, what I'm getting at is that no matter what kind of polygon we have, the sum of the exterior angles is 360. It's not even a formula. It's a constant. I don't care if it has 10 sides, 100 sides, or 3 sides. The sum of the exterior angles is 360. How easy is that? They're all the same. You don't even have to keep track of them. They're all the same. And then how do you find one exterior angle? You take 360 and you divide it by the number of sides. That's also for a regular polygon only. Cool. That is all of the lesson. Now we're just going to do examples. If you need to leave, you can leave. Find the sum of the measures of the angles of the given polygon. Find how many degrees are in a 30gon. When we don't know what its name is, we just put the number of angles and then put gon, just to let you know. So we would use our brand spanking new formula. We would do n minus 2. Oh, my minus and my 2 got merged. N minus 2 times 180. I think I had too much coffee this morning. N minus 2 times 180. It's going to be a large number. 28 times 180. 5,040 degrees are in a 30gon. 5,040 degrees. There's no such thing as a 1gon because it's not a polygon. It has to have at least 3 sides. If the sum of the measures of the angles of polygons is given, how many sides does it have? This one's a little bit tougher. This one you have to work backwards. So let's work backwards. N minus 2 times 180 equals 6,120. What's the opposite of multiplying by 180? Dividing by 180. So 6,120 divided by 180. Now, some people stop there, and that's why they get this problem wrong. They say, oh, it has 34 sides. But we're not done. N minus 2 equals 34. So what's the opposite of minus 2? Plus 2. You have to solve for n. You have to get n by itself. So 34 plus 2 is 36. And so the answer to this problem is 36 sides. That's a 6. Was that okay? Divide by 180 and add 2. You just undo it. You work backwards. A regular polygon is given. What is the measure of one of the interior angles? Whoa. So, a 15gon, we're going to use one of our formulas. N minus 2 times 180 divided by n. I know that looks kind of intimidating, but your calculator can do the rest. As long as you can write down the formula with the number plugged in, just let your calculator do the rest. You're going to watch this lesson 6 times tomorrow. Okay. 15 minus 2 is 13. 13 times 180 is 2,340 divided by 15. N minus 2 times 180 divided by n. The answer is 156 degrees. Here's the deal for Monday. I will let you use your formula and your notes on the quiz. I will let you have the quiz be open note. Heck, I'll let you use your homework on the quiz. I'll let you use your homework and your notes to try to get you to do your homework this weekend, okay? So Monday, I will let it be an open note quiz for you guys because this is a lot, and all of a sudden you're going to come back on Monday and we're going to quiz you over it, okay? Okay. Okay, V, if it's going to be irregular, I know y'all are worried about this. If it's irregular, like that, and I ask you to find a missing angle, I would have to give you all the other angles. I would have to say this one's 51 degrees, this one's 79 degrees, this one's 23 degrees, this one's 42 degrees, this one's 100 degrees. And then you would find the missing one. So you would just need to know, how do I find the sum of the measures of the angles? And you just add those up and subtract from that sum. That's how you do an irregular one. Okay. We didn't get to this one yet. The measure of one of the interior angles of a regular polygon is given. What is the name of the polygon? Okay, on this one, there's two ways to do this. There's a long way and a short way. Let me show you both ways. Here's the long way. Now, I bet some of you could solve for n, but I bet some of you have no idea how to solve for n. And it's not easy to solve for n in that problem. It's not easy to isolate n unless you really know your algebra. So I suggest you don't do it that way. I have another way to show you. If this is a polygon, I don't really know how many sides it has, but I know that one of the interior angles is 172.8. What I recommend you do is you find the linear pair to that, because you know what? Exterior is always easier than interior. So I'm going to do 180 minus 172.8. And I get 7.2. I'm going to work with my exterior formula instead of my interior formula. Here's my exterior formula. Oh my gosh, that's so much easier. So I switched from interior to exterior, and now my life is easier. You can solve this. Everyone can solve this. You can put this over 1, and you can cross multiply. 360 times 1 divided by 7.2. How many sides does it have? Whoa. 50 sides. It's a 50gon. What is the name of the polygon? You're correct. It's a 50gon. Are we okay with that one? You can watch that one again at home too. That was intense. But like I said, I would not do this way. You have to know the trick. It's tricky. You have to know the trick. Oh, that's all I have. Yay, we made it.